Hello and welcome to 7.1. In this section we are going to find the area between two curves. And as you probably could figure out, if you were going to try to find the area between any two curves, basically you could go about it and find the area under one curve between 2 points and then find the area. So like if I was doing this, it would be, okay, I'm going to find the area under f of x, which is this upside down parabola, all the way down to the x-axis. And then if I found the area under the g curve down to the x-axis and subtract them away, then I would end up with the area between the two curves that I was looking for up here. And so that is one way of doing it. You could do each part separately and then subtract them. Or we also said that we also are saying in this section that you could just subtract the upper curve minus the lower curve, and before you integrate and then solve, and you'll get the area between two curves. So it just kind of depends on your plan of attack. I will show you both ways, and it really doesn't matter. Sometimes it's easier to subtract first and then integrate, but it just kind of depends on you. It just depends on how many times you want to integrate. So here's our first example. And so I'll do it by the theorem, the example that I just gave you just a second ago. I'll do it by subtraction, and then we'll do it separately and show you that you're going to end up with the same thing. And that'll probably be the last time I'll do that for you. So if I'm going to find the area between these two curves, I would say, okay, well, I'm going between 0 and 1, and it would be kind of nice to know what these graphs look like. And I think I have a picture down here somewhere. Let's see what it looks like. I do. There it is. Oops, let's see, I got the picture down here. And so here's the picture between the two curves. You'll notice that the top curve was the x squared plus 2. It looks like a parabola going up, and the other one was negative x. And so what we're going to kind of do is, just like before, we're going to find the area. We're going to use the rectangles, and these rectangles will become more important as we go along here, especially when we get to section 7.2, that we're going to use these rectangles again to find the area between the two curves. They told us that we are going between 0 and 1. And so that's where the dotted lines, the vertical dotted lines, came from, the 0 and 1. And so then we're trying to find that red shaded area in the curve. All right, so if I was to do this, I would set up an integral just like this that would say, okay, well, I'm going from 0 to 1, and I know that x squared plus 2 is the top curve and negative x is the lower curve just by looking at the graphs of them. And so I'm going to say x squared plus 2 and subtract away the lower curve, and that whole thing would be integrated with respect to x. Well, I could kind of simplify this and make my life a little bit easier, and that gives me x squared plus x plus 2 dx. Now it's just like any other problem that we would do, and when I integrate this, let's see, I will get something like x cubed times 1/3 plus 1/2 x squared plus 2x, and this time I'm going from 0 to 1. So plugging in 1, I get 1/3 plus 1/2 plus 2, and plugging in 0, well, that zeroes everything out, so that's really nice. And so now it's just a matter of me getting common denominators and adding these up. Let's see, 6 looks like our common denominator, so I'm going to write these all over 6, and that means that's 2/3. That would be 3/6, or 2/6, 3/6, and in this case it would be 12/6. And so if I add those all together, the area between those two graphs is 17/6. And that's really all we're looking at for this, is that we need to find that area. So let's just try it the other way. The reason why I would subtract first is that I only have to integrate once, but you know, whatever, it doesn't really matter. So if I could do this from 0 to 1, find the area of the upper curve, and then subtract away the area of the lower curve. And you'll see I'll end up with the same thing. I'm going to probably take out this negative and turn it into a positive. I'll do that on my next step when I go ahead and simplify this. Actually, I think I'll do it right now. And so I get something like that. And so now I get 1/3 x cubed plus 2x plus 1/2 x squared and this guy is from 0 to 1, and this guy is also from 0 to 1, and so therefore you can see that this step right here, the only thing it saved me was just one step of integration, and by plugging in the values I'll still end up with 17.6 for the area between the two curves. Alright, so here's another example that we have up here, and so this one I'm just going to, since I have my graphs, I know which one's the upper curve and which one's the lower curve, I'm just going to subtract first and then integrate. And the trick with this one is, the difference is that in the previous example they gave us the endpoints where we're integrating to and from. In this one they're just saying find the area between the two curves, and in this case you have to find out where they're crossing. So what I would do is I'm going to set these guys equal to each other, because that's when they're crossing each other. And yeah, you can probably look at the graphs and see them, but you never know if you're going to have the access to a graphing calculator. So if you don't have access to a graphing calculator, what you're going to want to do is say 2 minus x squared equals x, because that's where they're crossing, is where they're equal to each other. So I would go ahead, and to find those green spots is I'm going to solve this. I'm actually going to add x squared across the equal sign because I like a positive x squared, and I'll subtract the 2. So really I have 0 equals x squared plus x minus 2. Now remembering back to algebra, we would factor this, would be a good plan of attack. x2, x1, and I know that my 2 has to be positive so that I get a positive x here, and so I get something that looks like this. So the places, when I do my zero product property, x plus 2 equals 0 and x minus 1 equals 0, is that x is negative 2 where they're intersecting and x equals 1. So that should, yeah, my graph kind of looks like that. I see negative 1, negative 2 down here, positive 1. That looks pretty good. So those are my boundaries for my integration of f minus g. So remember that we are going to integrate this from negative 2 to 1 of f of x minus g of x dx. So it's just a matter of now dealing with it. So from negative 2 to 1 of 2 minus x squared minus x dx. And you can put brackets or parentheses around it if you like. For some reason I lost my negative 2. 1 there. Okay, so then I will just continue on with this, and so to integrate this I would say, oh okay, well 2 goes to 2x, negative x squared goes to 1/3 x cubed, negative x goes to negative 1/2 x squared, and again we're going from negative 2 to 1. So I'm going to move way over here to plug in my values. The upper value is 1, so it's 2 times 1 minus, well, 1/3 times 1 cubed is just negative 1/3, and again then we get minus 1/2, and then we get to subtract away the second half, which is 2 times negative 2 minus 1/3. Now negative 2 cubed is negative 8 minus 1/2 of negative 2 squared, which would be positive 4. So this is a little trickier just because we didn't get 0 as one of our endpoints, and so we got to do a little bit more work. So we still have 2 minus 1/3. So on this side, I'm not going to, you can go ahead and go with common denominators right now, but I'm going to wait because I might have other things that I can kind of add and subtract together, and then at the very end I'll go with common denominators. So I have 2 minus 1/3 minus 1/2 over here. Now I'm going to distribute this negative to everybody and hopefully fix some of the signs. So this turns into negative 4, but changing it negative becomes positive 4. This is a positive 8/3, but it becomes negative 8/3 because of I end up with 1, 2, 3 negative signs. And then I end up with a negative 2 over here, but it becomes positive because I end up having 2 negative signs, so we end up with positive 2 for that one. So combining my numbers, I've got 2, 4, and 2, and they're all positive. So that looks like I'm dealing with like, well, that looks like 8. And then minus 1/2, we'll deal with that one because there's no other halves to deal with. And then minus 1/3 and minus 8/3 combines together to give me 9/3, which is also subtracting 3. So we have 8 and minus 1/2, minus 3. So 8 minus 3 will give me 5. So we're saying 5 and subtracting a half, and so common denominators say 10 over 2 minus 1 gives me an area of 9 halves for the area between the two curves. And that's really what we're looking for, is how do we find the area between the two curves? Well, that's the way you do it. So if you have any questions about this, we will cover more of this in class, but please come to class prepared to ask these questions.